Hello, everybody. This is Alexey Kovyazin, President of Firebird Foundation. As you know, Firebird 5 is really close to release, and it's a good time to study new features and to see what advantages Firebird 5 will bring to the community of Firebird developers. And today I am announcing a series of articles and videos about Firebird 5 new features. We will publish detailed explanation and all details about all features of Firebird 5. Today, the first part of detailed explanation of new features of Firebird 5 will be devoted to Optimizer. Optimizer is very important part of Firebird 5, and let's see why. Let's make a quick review of new features of Firebird 5, and let's start with Optimizer. Firebird 5 is focused on performance. Almost all features, all changes in Firebird 5 are intended to improve performance, and especially Optimizer. The good thing about the Firebird 5 that Optimizer is targeted to improve existing applications. It means that you don't need to change SQL queries to reach the new level of performance. There were a lot of investments to the optimizer during the development of Firebird 5. Number of changes in optimizer is biggest since version 2.0 of Firebird. There are at least 8 points we would like to cover in this video. And of course, these points are considered in much more details in the article which is supplied in the same post and in the description of this video. But let's start. Why optimizer is so important for the performance? The answer is not so simple as it could be. Inside Firebird, optimizer is a part which is responsible to actual execution, actual low-level execution of queries. Imagine that we have a table with ID, name, and index for ID, and very simple query as on the screen. Select from table where ID is greater than 2024, order by ID. The optimizer should answer the questions to execute even this simple query. Should we use index to filter records by ID or not? For example, if this table is really small, using of index is not a good idea. It will be slightly slower than the natural reads. Should we use index to order records or should we use external sorting? The answer also depends on the goal of this query. Should we extract all records and sort them, or should we just show the first records in the grid for the user and that's all? So this is really not a trivial task, and the result of optimizer's work is execution plan. How to see the plan of any query? In the standard tool iSQL.exe, if you will open the tool, connect to the database and type the command set plan on. After that, after execution of any query, you will see the plan for this query. There are two forms of the plan: legacy or simple one, you can see it here, and explaining plan, more advanced, which is available since the version 3 of Firebird. Plan shows how Firebird will execute and build the result for the query. Let's see on the example the first improvement, the first very important improvement in Firebird optimizer, cost estimation of hash versus nested loop join. Imagine we have a very simple query, select all from persons, inner join countries by country ID. In this example, table persons has many records for obvious reasons, and table countries is 200 records, let's say. And usually when the Firebird executes such query, it will use the well-known nested loop join or inner join if we are speaking about the legacy plan. Nested loop join will work in the following way. For each table, for each record, Firebird will search for the matching records in joining table and put it to the output result set. For the situation when we have a very long table and join it with very small table, it means that there will be a lot of repetitive reads of the small table. So if we have, for example, 7 or 8 billion of records in table persons and only 200 records in countries, it means that anyway for each record fetched from the table persons, we will need to read the same, not the same, but the record from the countries. It means that a lot of repetitive reads of table countries. Since Firebird 3 exists a better way to treat such situations. It's a hash join. The idea of the hash join is really simple to explain in the simple words. Let's just cache the small table, not all, but what is required for the joins, build the hash function to find the matching records, and keep it in the cache. In this case, the small table, will be read only once, cache it, prepare it for joining through the hash, through the hashes, and it could give us up to 3, 5, depending on the situation, faster results. In the article, with all details, you will see the example of the improvement by more than 3 times. Okay, but how to make optimizer to use hash join? In Firebird 3 and 4, it is necessary to use non-indexing condition to force optimizer to use hash join. For example, we should add +0 to turn field comparison into comparison of expressions. The Firebird optimizer will see that there is an expression which gives the same result, of course, because +0 does not change the result. But this expression will be not indexed because there is no index for such expression. There is index for pure field. And if Firebird will see that there is no index for this join, it will try to use hash join to do this optimized joining of small table to the bigger table. However, it's not really convenient, not very suitable. You need to change your queries, right? And it could be a really big work. And here comes the good news. In Firebird 5, this change of plan will be done automatically. The Firebird will calculate the effectiveness of plan with hash join or with uh, inner join. Oh, let's call it inner join, and select what will be the best for your query. So essentially, it means that you don't need to do anything with your queries. Just run it on Firebird 5 and they will be automatically improved. In some cases, it will be like several times faster. Really good. Second improvement, also related with the hash join. Before Firebird 3, there was no hash join, but there was a way to join non-related data sources. For example, if we will see this example, it's really simplified, not real, but just to demonstrate the situation. So we have two different data sources which do not have indexed connection, indexed relation between these data sources. How we should join them if we want to present some result? For example, in this type of query, so we have some select and subselect from one dataset and another dataset, and we join it for client ID connection. In order to join records from these datasets, Firebird should do the Mer Join. How the Mer Join works? Firebird need to get the data from the first subselect, sort them, then get the data from the second subselect, also sort them, and after that, join record by record, record by record. Of course, it's not really fast, but in situation like this, there are some real situations when we need to have this type of joining for some complex reports, for example. Looks like it is the only way. However, in 5.3, as we remember, we have the option for using the hash join. For example, if one of these joining data sources is small and another is large, we could use the hash join. I mean, we could cache all records from the small data source and use it to join to the big data source. And in this case, resulting data set will be generated much faster. Oh, however, it is not so simple, or let's say it was not so simple. Why? Because in version 3 of Firebird, the Mer Join was disabled because of the hash join, and all such joins are done in Firebird 3 and Firebird 4 only with hash. But there are some situations, for example, when the data sources are, both data sources are big or are equal size, it does not make sense to try to cache the one of the data sources and use the hash join. It is really better to use merge. And here comes the improvement for optimizer. Now optimizer in Firebird 5 can decide, can estimate what is better to use, hash or merge. It's not perfect. There are some restrictions, some limitations, but it's a big step forward. And now the optimizer have more options. The third improvement of optimizer in 5.5 is also very important. It's transformer outer join into inner join. Let's imagine that we have the following query. So join clients with invoices using the left join, and we have a filter on invoice to filter invoices only for 2023. Since this is a left join, we will have as a result data like client invoice. And for clients which do not have any invoice yet, we will receive null, because this is how the left join, outer join works. However, in this query, we also have a condition for the date. And this condition effectively filters out records from invoices which are null, because this condition does not allow nulls. It means that essentially the query looks like this. We don't need left join. Of course, this situation occurs in dynamically built queries very often. So when you are building some report or complex query, it is difficult to know where will be condition for right side for the date in this case, or it will be no condition and the left join should work as it should work with nulls in the right table, in the data source which is joined on the right. And for Firebird, it means the following. So implicitly the query, the example of the query is using the inner join, because it filters records with nulls. But Firebird must follow the order which is specified by the left join condition. And in this case, it means that it will read the whole table of clients. Yes, it's smaller, but it is still all clients to be read. And it will not apply any index for invoices, because it is forced to execute join in the order specified in the left join. And in Firebird 5, there is a solution for this situation. Firebird 5 will recognize this situation and will try to select best possible plan to execute, best possible way to join tables in this situation. And again, it will not require any changes in your code. It will just work automatically. Improvement number 4, preliminary evaluation of invariant predicates. Well, it has pretty complex name, but in fact, this is pretty simple for the users, of course. Imagine we have this query. This query, these types of queries is usually built by some automatic tools or dynamically built queries. And this type of condition means I don't want to execute this query. How the Firebird 4 and Firebird 5 will execute this query? In Firebird 4, engine will read whole table, because in Firebird 4, optimizer is not smart enough to understand that this predicate is actually prohibits reading of all records, and it should return 0. And in Firebird 4, Firebird will read all records from the query, apply the condition, and of course it will end with 0 records as a result, but it will be slow. In Firebird 5, optimizer is smart enough to understand that this condition is actually prohibits returning of any records, and it will return 0 immediately. In the article, you will see the detailed statistics, and the plan for the execution is really interesting. Don't forget to read it. Okay, improvement number 5 in Firebird 5 optimizer is faster in with list of constants. In version 4 and below, there is a limitation. Only 1,500 elements could be in list of in with constants, and internally optimizer will transform this list into bunch of OR. With bigger list, it works slower and slower. To optimize it, Firebird 5 introduced new way to treat in with constants. Firebird 5 will transform it into the binary tree, sorted binary tree, and use much faster technique to filter records with elements of in. Also, the limit, the maximum number of elements inside in with constants will be 65,000 of elements, and it really works much faster. You can see in the article some examples of how it works and what is the result of this improvement. Also, it does not require any efforts for you to use to see the improvement of your application, and if your queries use in, it's definitely you will notice the difference. The next change in optimizer of Firebird 5 will affect the majority of select queries. It's optimization strategy all rows or first rows. In general, first rows is a strategy when optimizer builds query plan to return as soon as possible the first rows of the resulting dataset. And all rows is when optimizer builds query plan to return all rows of the resulting dataset as soon as possible. So internally there are differences in data sources where could be conveyors and buffered, but all these details is better read in the article. We will just notice that these strategies actually existed in before Firebird 5, but there was no way to control which one to use. The default strategy was to return all rows, and engine optimizer in Firebird 4 below had optimized only clauses first rows or subselects to return first rows. Now it is possible to manage optimization strategy with the parameter optimize for first rows, and also in additional clause for select to optimize, for example, optimize report to return all rows as soon as possible, or optimize to receive first records to show in the grid. Also very interesting parameter. Please read more details in the article. And last but not least, we have the following minor improvement in optimizer: improved plan output and stored procedures plans. Improved plan output allows developers, Firebird users, to recognize the problems in queries, to identify what is going on inside the complex queries and better understand it. And stored procedures plans It's a long history that in Firebird 2.5 there were some kind of plans, but they actually were not plans. It was a bunch of plans of queries inside the stored procedure. In Firebird 3 and Firebird 4, all stored procedures had plans as natural without any details, so it was not possible to analyze it. But in Firebird 4, in Firebird 5, appeared a good way to see the plan for stored procedure inside the monitoring table non-compiled statements. The details and example how to do it also is in the article. Okay, this is all I wanted to tell you about the new features in Firebird 5 Optimizer. Of course, to better understand all details, please read the following article. There is a link to it in the description of this video and also in the news on the Firebird SQL website. And of course, stay tuned for the part 2. We will describe in details what's new in SQL of Firebird 5. And there will be also video with some introduction like this one and in-depth article with examples with all things necessary to understand new features of SQL and how to use them. Please subscribe on our channel on Firebird, on our Firebird channel on YouTube, and watch for news on Firebird SQL. If you will notice an error or if you will have any questions, please write to me to this email ak@firebirdsql.org, and I will try to answer all your questions. Thank you very much for listening. Bye.